guys, welcome back to the Tech Seminar. And today we are diving deep into the topic of quantum computing. Yeah, you might have heard about that thing, right? Quantum computing. What is it? Is it a kind of computing? And it is related to quantum. It might be related to quantum mechanics, right? Yeah, it is. Quantum computing is a field of computing where we leverage the principles of quantum mechanics to accelerate the computing power that we have. After the introduction of quantum computing, the computing was divided into two: classical computing and quantum computing. The computers that we currently use are classical computers. The classical computers can only have two numbers, can understand information only in two ways, in the form of bits, whether it is 0 or 1. But in the case of quantum computers, they process information in the form of qubits. Qubits is a bit equivalent of quantum computer where a qubit can take the values 0, 1 and a superpositioned state of 0 and 1. What I mean by a superpositioned state is that it is a state which exists as a combination of 0 and 1. And this is what I mean by superposition of 0 and 1. So sometimes the 0 might be the dominating thing, or else 1 might be the dominating factor. So these things matter. Then, what is the purpose of building a quantum computer or diving or researching about quantum computing? Well, we already have classical computers. Well, there are a lot of problems that needs to be solved with great precision and great speed. There are a lot of limitations with classical computing because classical computing is limited by its speed. Yeah, when we try to model the things which happen in our nature, like the movement of a leaf, if we try to mathematically model it using a classical computer, how a leaf will fall in the presence of air, it will be a very hectic mathematical modeling, and it would take enormous hectic number of years for that for that computer to model it. You might think that why not use a supercomputer because supercomputer has such a great computing power, right? But yeah, even the supercomputer is not efficient. It's not enough to do these kinds of things. We need bigger, we need more advanced things to make it a reality, to make it possible. So, this is where the quantum computers step in. Quantum computers can simulate the nature itself, it can behave in the way how nature behaves. Yeah, that's what happens. So, the other thing which matters about the quantum computers is that quantum computers give us enormous leverage, enormous power over cracking the cryptography, not cryptography, the encryption. The encryption is based on the fact that the classical computers cannot find a solution to a problem. Yeah, if there exists a problem which is related to prime factorization, I'm not going deep into that problem, but realize that there exists a problem which a classical computer cannot solve. When I say a classical computer cannot solve, you need to realize that what I mean is it will take a long years for a classical computer to come to reach the solution. It might be hundreds or thousands of years. So this principle is employed by encryption. Encryption is based on it. But once a quantum computer is made, quantum computers can do these computations within few minutes, which means that we can break the encryption instantly. It will not be a big obstacle to break encryption. Yeah. This is the factor, this is the truth. You need to work on it. You need to realize its effect, the way it is gonna influence the whole world. And that's why the famous physicist Michio Kaku has written a book called Quantum Supremacy, because quantum computers are gonna rule the world in the future. When I say quantum computers are gonna rule the world, it doesn't mean that our laptops, the classical computers that we commonly use, are gonna replaced by them. No, that's not what I mean, because quantum computers cannot replace everything. Still, we will need classical computers because quantum computers are specialized for specific purposes, and they are greatly useful for those particular situations or scenarios. That's when the supremacy of quantum computers are clearly visible. Yeah, these are the things about quantum computers and its effect on this world. Quantum mechanics is a vast topic, and if you ever get a time, please try to understand the principles of it. I'm not asking you to go through the mathematical concepts, and no, that's not what I mean. You can just watch some animated YouTube videos to understand what each principle in a quantum mechanics, each principles in the quantum mechanics convey or mean, because we will be fascinated by the facts or principles that are spit out by quantum mechanics. So if you don't know what is quantum mechanics is a branch of physics which deals with subatomic world. Uh, if you don't know what is subatomic world is a universe, or is a world of atoms which are the building blocks of everything that we can see around us. Yeah, this is the thing about quantum mechanics and quantum computing. And I do hope that you can perform well and do greater things and build for the future using the principles and the information that I have conveyed with you. And by this, I'm ending my session. I hope you have got a better idea and enhanced information about what is quantum computing and why it matters. And thank you.